Hello students, today we are going to see something important. Come on, let us go for it. Dehydration of which one of the following alcohol produces an alkene exhibiting cis and trans isomer? They have given that alcohol. In that alcohol, which that is definitely give that alkene only, we are going for what it is, dehydration. Yes, but in that which alkene is having cis and trans isomer, they are asking. Okay, now what do you mean by cis and trans isomer? Cis and trans isomer is nothing, a pair of molecules having a same molecular formula only, but a different orientation, different functional group as having different orientation. It is when it is there in the three dimensional. Now for example, carbon A, here B, and here C and D. Here this side carbon B and A, here C and D. So same molecular formula only, but different orientation, the functional group which is attached in the different orientation. So that is called cis, and this is normal cis, and this is trans from that trans. So this is called cis and trans. Now let us find out in that alkene is having, this is I have given an example. Okay, now let us go and identify isopropyl alcohol. The first one, isopropyl alcohol, CH3, CHOH, CH3, right? Undergoes dehydration in the presence of acidification. Okay, now it release water. So I just put it a small rearrangement, CH2 hydrogen here, so the water molecules release. So definitely this bond goes over here. So what is the formula you are getting? CH3, CH double bond CH2. Okay, now let us find out whether it is having a cis or trans isomer character. Okay, now CH3, H double bond C, here one hydrogen, here one hydrogen. I just mentioned a different functional group, but here both are same. So same group means it does not have the character of cis and trans. Okay, fine. This one, it is not possible to get an answer. Okay, the second one. Second one, what it is? Tertiary. This is very easy. CH3, 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 here OH, and the presence of acidification, water release. Okay, here one small rearrangement, CH2, here hydrogen. I just put it like this. So here carbon, here CH3, CH3, double bond CH2. Okay, now water releases means naturally what happened? This bond. Okay, so it's double bond CH2. So as you are going for like this way, this also it is not possible because both the side hydrogen, hydrogen, same group. It is not possible only. So this also not the correct option. Then third one, long chain structure, N-butyl alcohol. What is it? N-butyl alcohol, what it is? CH3, CH2, 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 1, 2, 3, 4, OH. Okay, I just put it a small rearrangement like this. Here OH, is it visible? And here hydrogen. I just put it here one hydrogen here, one hydrogen down. Why? To remove the water molecules only in the presence of acidification, water releases. Okay, so here what happened? The water releases. So you will get what it is? CH3, CH2, CH double bond CH2. So here also two hydrogen, there is no different functional group like, so we cannot go for this third option also. Okay, now let us go for that fourth option. Neopentyl alcohol, carbon CH3, CH3, here CH3, CH2OH. So this is neopentyl alcohol, undergoes dehydration. Yeah, this is water release, of course. So how it will go and relay that water? So now for example, here one hydrogen, we just relay that. So small rearrangement. So here what happened? The water molecules release, so automatically this bond comes over here. This will go and attach over here. So that means CH3, C, here CH3, double bond CH3. Okay, so this one which will go and attach over here. 1, 2, 3, 4. Yeah, this carbon is having 4 bonds. Yes, I. This one, this you will get it actually what is a alkene, but this also does not have that what it is, a different group. Okay, now for example, if you take this point, you are not having that. Okay, so that means this is also not having a proper option. Now the next one, last one, pentane triol. That means 3 pentanol. Okay, now fifth one, CH3, CH2, CHOH, CH2, CH3. Okay, 1, 2, 3, 4, 5. So the third carbon, 1, 2, 3. Third carbon functional group it is there. So that's what it has mentioned. 3 pentanol. Okay. Oh, this goes what it is in the presence of dehydration. Water molecules release. Okay. Now here one small rearrangement over here. Hydrogen. Okay. Now water releases. So what is that answer? You will get it CH3. CH, a double bond, CH, CH2, CH3. Yes. Okay. Now let us find out whether this is having a cis and trans isomer. Yes. Now for example here CH3, CH double bond CH, CH2, CH3. Yes. Let us go and identify. Yes. Now here, just I'll put it that carbon double bond here. This side hydrogen, this side CH2, CH3. The same way here hydrogen, here CH3. Right. Now just to the opposite side. Opposite side. Now for example, here opposite side here CH3. I just put it a small so that it will be easy. Okay, C double bond. See here, one side hydrogen, one side CH2, CH3, the other side hydrogen, the other side CH3. Okay, now opposite side, just a C double bond C, here CH2, CH3. CH2, CH3, here one hydrogen. Here this side what it is? Hydrogen, the same CH3. Okay, now this is a cis and this is a trans. Okay, that means neopentyl alcohol. It is possible. So that means which is the correct option? E is the correct option. So this is the way if you find like this means you are your answer is correct. Now I would like to give one more. It is possible or not? You check it. Now 2-butyl alcohol. 2-butyl alcohol. Alcohol, whether it is possible or not, you check it, because one more question also I have seen like this. Okay, in that question they mentioned 2-butyl alcohol. Okay, now you just check it whether 2-butyl alcohol is having cis and trans isomer. Okay, please put it in the comment box whether it is possible or not. Okay, fine. Is it, can you follow this? Let us go for the next question. Next, that is also a little bit similar question only, but something different. Which of the following is not the product of dehydration? Dehydration, it is nothing. Elimination reaction release that water in the presence of acidification. Yes, this is also alcohol, cyclohexane compound. Yes, let us go to find out this. Okay, now which is not the product they are asking? That means here OH it is there, here one CH3 group. Okay, now here which is not the product. Okay, so as it is released that water, so you will get the carbocation on this side. No, okay, here acidification, elimination reaction. Okay, now here what it is, here this is not the benzene, this is cyclohexane compound. Now here you will get this, what it is, carbocation formation. You will get this side carbocation formation. So that means the hydrogen here one hydrogen release, so naturally you will get what it is, the double bond character, you will get it right, relieving water. Alkene, the product, last question we have mentioned, so the double bond comes over here, or the double bond comes this side also. Okay, now or else the double bond comes here. Okay, now like this side also it will be coming. Okay, or else it may come this side also, but it is not at all possible inside. Why? Because OHs represent this side. How come it will go and attach over here the double bond, the water molecules takes that hydrogen from here or it may be here on also. Okay, tertiary carbon, no, so it may take it from this side or this side or this side, not at all from inside. That is what. Now, which is in that way they have given. Now, this is also possible. See, which is not the product. That means which is having that product means this is also is having that. It can give that product. This also it is possible, but this is not the product of this compound. Okay, when it is goes for the dehydration elimination reaction releases water, you will not get this kind of that product. You may get this kind of the product. Why? It takes out that hydrogen, so naturally what it is, alkene formation where you will get that formation. So this side, see, because here hydrogen, one hydrogen takes it over. Last question we have seen, no, the same idea we can bring it over here, so naturally you will get this side, or here this side also you can take it, this side also, but not inside. So inside only they have given. So that means that is not the product, easily to identify. So where there is OH nearer by, you can. And moreover, this is tertiary carbon. In that way, you can identify. Hope you're clear with this. The next question, really, it is interesting. Sodium tertiary butoxide reacts with the ethyl chloride. It gives tertiary ethyl ether, tertiary butyl ethyl ether. Okay, now they have given the equation. You have to find out what is the naming reaction, who has invented this reaction. Okay, now first and foremost, Williamson synthesis. Second one, Gattermann's Koch. Third one, Williamson's continuous etherification reaction and Etard reaction. Okay, we'll go from here. Etard reaction, actually, methyl benzene toluene converted into what it is, benzaldehyde. So methyl benzene converted into benzaldehyde in the presence of chromyl chloride. It's very very important, that is aldehyde part, not from here. Okay, now this is wrong. Now Williamson's continuous etherification, yes, it is related, but theoretical only we are going to follow, not in this. And one more thing, we are going for the primary, what it is, ether only, but here it is what it is, a tertiary, so we will not come over here. Okay, now next one, Gattermann's Koch. Gattermann's Koch, benzene converted into benzaldehyde along with what it is, carbon monoxide in the presence of alumina. So this also, which is not possible. This is actually Williamson's ether synthesis, that is the correct option. The Williamson's ether synthesis only directly they will give. Sometimes they may give like this is very easy. Always you will go for that Williamson's ether synthesis. This also, like, you will get confused, but this one we are going for theoretically only, but this is only common, we used to go for it. Hope you understand very clearly. This is etherification. Esterification is different from etherification. Hope you're clear with this. The next question, really, it is very simple. Arrange the following compounds in the increasing order of acidic strength. They have given this meta-nitrophenol, metacresol, phenol, metachlorophenol, and they have given that increasing order. Okay, even in our last session we have gone through the same concept but a different question. Okay, which is more acidic, like which is a weak acid, like they mentioned. But here the questions, the concept is the same, question different. Yes, let us go further to analyze it. The first one, what it is, metanitrophenol. The first one, what it is, metanitrophenol, NO2, right? The second one, metacresol. Here OH, CH3. And third one chlorophenol. Oh yeah, third one, sorry, phenol. This is phenol. This is phenol. Easy. Fourth one, metachlorophenol. Yes. OH, here Cl. Okay, in this, which is that having more acidic? First and foremost, nitro group is present. Our eyes will fall on nitro group only, because among all this nitro group, very good leaving group, and actually what it is, electron withdrawing group. Electron withdrawing group. So naturally here density of electron density will be decreasing, and easily you can remove the proton. So acidic strength will be stabilizes due to that nitro group. So naturally this will be more acidic. Okay, now as we come to know this is more acidic, that means which one will be the first option. So this is, yes, we'll come to know this and this. In this we cannot go for it, because this is more acidic. First and A option and D option, let us go for it. Now the second one, what it is, the second one, chloro group is there. This also electron withdrawing group, of course this also it is nearer to that. Yes, this also we can say more acidic comparatively other than these two. Next one, X. Fourth one, next one, what it is, phenol. Of course it's a weak acidic only, but comparatively what it is, metacresol, it is very least one. Last session we have gone through metacresol. Why? Because electron donating group it is there, but these are this one electron what it is, withdrawing group, whereas here electron donating group. So what it is, electron density will be increasing on oxygen, so this is very difficult to remove that proton, so naturally acidic strength will be decreasing. So as that what it is, electron density on oxygen which is increasing, so it is very difficult to remove the proton, so definitely acidity will be decreasing. So which is that correct option? A, B, C, D. So this is first one, it is more acidic. More acidic. Okay, now this is the next one. First one, second one, and third one, phenol, of course, third one, and fourth one. So in that, which is the correct option? Already B and C is knockout, and this one, 3, 4, 2. No, this is not the correct, and this is the correct option. 1, 2, 3, 4. 1, fourth option is 2, third option it is 3, of course, and fourth option, fourth one, it is 2. Yes, this is the correct option. Hope you're clear with it. So in that way, you just remember that electron withdrawing group where it is, and what about cresol? Wherever cresol comes, that is least acidic. Okay, why? Because electron donating group with, actually electron density will be increasing, so it is very difficult to remove the proton. So those points and all you please remember. Hope you understand this point. The next question also, it's very important. Phenol on treatment with carbon dioxide and the presence of sodium hydroxide followed by acidification produces a compound X as a major product. X as a major product. That X on treatment with acetic anhydride in the presence of catalytic amount of H2SO4 produces what? Okay, phenol combined with carbon dioxide and the presence of sodium hydroxide only, you will come to know that is Kolb's reaction. You are getting salicylic acid number of times we have seen in the naming reaction. Yes, so whenever you are getting phenol, carbon dioxide, sodium hydroxide, and high temperature and pressure, last session also we have gone through that. Yes, let us go for that reaction. The first one, X compound, we will find out. Already you know, but still I would like to write it for you to remember. Okay, now this one, yeah, I just put it here. This is OH, phenol reacts with carbon dioxide and the presence of NaOH. High temperature and pressure and hydronium ion. Yes, acidification. You are getting salicylic acid. What acid we are getting? Salicylic acid. Here OH, here COOH. Okay, now suppose here if it is OH means here COOH will be there. Now here purposely I have written for that we should get the answer. That is the reason. Okay, this is called what it is? Salicylic acid. Okay, now the salicylic acid to hydroxy benzoic acid also we can say. Okay, yeah. Next one, the second compound. This X on treatment with acetic anhydride. Again, it reacts with acetic anhydride. The salicylic acid. Again, it reacts with what it is? Acetic anhydride. That is OH. Here, COOH reacts with acetic anhydride CH3 CO. Here CH3CO. These both combine together O in the presence of H2SO4. Okay, now this hydrogen combined with this point, you will get CH3COOH. So that means what it is? Acetic acid, right? Okay, now you will get what it is. That is a minor product, CH3COOH, acetic acid. Then remaining what it is? This O combined with the C. Okay, I just put it here. Okay, now this is O. Then here CO, right? C, double bond O, carbonyl group. Here CH3, then here COOH. Yes, you got it. Now this means O. This hydrogen has joined over here. You are getting acetic acid. Okay, now that is a minor product. Okay, now next one here O. It is there. This O combined with C, double bond O, and CH3, COOH as it is. Now this is what it is. Acetyl salicylic acid. What do we say? Acetyl salicylic acid. Acetylation. Friedel-Crafts reaction. Hope you remember. Okay, now how do we get acetyl salicylic acid from phenol? This is only. Now compound X is this one. What is the compound? Major compound X. This is salicylic acid. And from that we are getting what it is? Acetyl salicylic acid. Acetyl salicylic 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 acid, right? Okay, now which is the correct answer? Now we have to check it. Okay, now this is CO, C double bond O, CH3, and this side actually we put it here purposely to get the answer. This is next to that only you will get that. Now this will not be the correct answer. Maybe formula correct, but position it is not correct. And this is what it is. C double bond O here C double bond. What is this? It's not at all in the list. Okay, now next one. Here dicarboxylic acid. It is not possible for dicarboxylic acid at all. Okay, now this option is standing over here. Option D, it's a correct answer. Hope you're clear with this option, and it's very important. You know, this is actually what it is. This reaction, it is called Kolb's reaction. Kolb's reaction. Okay, so Kolb's reaction means you have to remember one thing, it is salicylic acid. The other thing, from salicylic acid, how do we get to what it is? Acetyl salicylic acid, that is acetylation reaction. So you have to remember both the things. Friedel-Crafts reaction also you have to remember, and you have to remember Kolb's reaction also. Kolb's reaction means salicylic acid. Acetylation means what it is. Friedel-Crafts reaction means acetyl chloride also will be coming. Acetic anhydride also will be coming. Acetic anhydride you will get aspirin. This is also acetyl salicylic acid also is known as aspirin. Aspirin. This is very important. Please remember this. Aspirin, RIN. Okay. Hope you understand this. The next question, it is very interesting and important also. Which of the following reagent would distinguish cis cyclopenta 1,2 diol from trans isomer? How can you differentiate this cis cyclopenta 1,2-diol from trans isomer. Yes. Okay, that means it through this reagent which will be distinguished. That means differentiating reagent. Okay. First and foremost, we'll go the formula cis penta, cyclopenta, 1,3-diol. Sorry, 1,2-diol, right? Okay, here OH, here OH, 2-diol. Okay, dihydric alcohol. So 1, 2, 3, 4, 5. Okay, now this is combined with, okay, let us go for acetone first. Okay, now acetone, I just put it like this, double bond O. This is CH3, CH3, C double bond O, CH3. I put it in this bond, like a bond line structure. Yes, it releases water molecule. How come it releases water molecule? Here one hydrogen, along with this oxygen, you are getting water molecule. Now, what is the what it is a structural formula? Here the same thing only will be there. Here one oxygen remaining, here one oxygen. These both connected by this here CH3 like this it will be there. Okay, now this is actually a ketol formation. Ketol formation. Okay, see, generally alcohol reacts with ketone, you are getting ketol formation. Okay, now that is the way you can differentiate cis and trans. Okay, now in this acetone combined with what it is cyclopenta 1,2-diol to form here bicyclic compound you are getting, whereas this acetone cannot give the trans isomer, it can give only the cis isomer. Why? Because it has an angle strain in the trans isomer. Angle it will be vary. How that angle will be vary? Hybridization we have gone through, no, each one having the different angle. In that way if you go through, you will get into that point. So here bicyclic compound can give with this acetone along with cyclopenta 1,2-diol, you will get that bicyclic compound that is also known as ketol, whereas trans isomer you cannot get. That is the way you can differentiate. So this is the correct option. Ozone, no, this is not possible, and this is also not possible. Manganese dioxide, yes. Aluminum isopropoxide and ozone, no, these are all not possible. Which one it will differentiate easily? Bicyclic compound, whichever it is giving, that is the way we can identify. The next question also, it's very simple. Here, cyclopentanol reacts with sodium hydride. You are getting what it is, like sodium cyclopentoxide, like that you are getting, and this is reacts with methyl iodide. You are getting OMe, that means ROR. This is, don't you think so in that way? Okay, now they are asking naming reaction. Which reaction it would have been? See here, can be classified as, see, like naming reaction only this is. So this is ROR, open to ice, like it's easy to identify. This is ether only, ROR, it is ether. Dehydration reaction, removal of water, no, not in that concept. Yeah, Williamson's ether synthesis, yes, it is correct. Williamson's alcohol synthesis, it is not at all. Williamson, it's not preparing the alcohol only. Now, alcohol formation reaction, no, this is not alcohol formation, this is ether synthesis. So, this is 100%. So, very simple only. See how they are asking in a tricky way to confuse us. If we know the concept well, whichever question, whichever they are asking in a different way, twisted way, indirect way, whichever way they are asking, concept we are thorough means we are able to crack out all the questions. Hope you understand all these questions. Some more question will do for some other session. Yes, thanks for watching.